Hey YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic1. In this video, I will be doing a walkthrough of HackTheBox Codify vulnerable host. I will be delivering a detailed walkthrough of the entire process, from reconnaissance to post-exploitation. This will encompass port scanning, service enumeration, arbitrary file upload, remote code execution, database exploration, password cracking, and privilege escalation. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on www.cybersec.com. HackTheBox Codify is a Linux-based vulnerable host developed by Kavigion. It is designed for users to practice ethical hacking techniques on a Node.js web application. This challenge offers a well-rounded learning experience including web application testing, database enumeration, password cracking, and exploring privileged escalation paths. The target host is available within the HackTheBox Training Lab environment. I've started my target host Codify, which now has an assigned IP address, as shown on the screen. The first step in the process will be information gathering, beginning with port scanning and service enumeration. For active information gathering, I am utilizing nmap on the target host. I'll run the following command shown in the CLI. To identify all open ports, I'll initially scan all 65,535 ports using the -p-switch. This performs a comprehensive discovery scan to ensure that nmap detects services listening on both standard and non-standard ports, which is crucial when attempting to perform thorough reconnaissance. Upon reviewing the nmap scan results, I observed that nmap detected 3 open ports: port 22 SSH, port 80 HTTP, and port 3000 HTTP. As I analyzed the nmap scan results further, it appears likely that Codify is a Linux host. This assumption is based on nmap's detection of a generic Linux OS, Ubuntu displayed in the service banners, and the presence of an SSH service. Given these indicators, my first focus will be on examining the service running on port 80. On port 80, the web server is running Apache version 2.4.52. Additionally, the scan indicated the presence of another page, http://codify.htb/. Based on the limited information about the host, I would assume that the other HTTP port 3000, is hosting http://codify.htb. I'll look at port 3000 later. I attempted to browse to the target host's IP address, but received a server not found error with the web address displayed as codify.htb. This typically indicates that the hostname/IP address needs to be added to the /etc/host file. To resolve this, I ran the following command shown in the CLI to add the IP and hostname to my system's host file. After adding the IP and hostname to my system's host file, I was able to browse to the codify.htb webpage. Preliminary review of the page indicates that the web page is running Node.js. I could also see there were 3 links to review: /about, /editor, and /limitations. On the /about page, it shows that the VM2 library is being used, and there is a hyperlink that redirects to a VM2 GitHub repository showing version 3.9.16. On the /editor page, it shows a box that appears to allow you to run JavaScript code. Reviewing the page source, I don't find anything useful other than the editor run function uses the post-HTTP method. Looking at the /limitations page, it notes that there are some restricted Node.js modules, and also notes what Node.js modules are whitelisted. I'll use fuff to run the following command shown in the CLI to crawl the web server looking for hidden directories and files. The fuff scan completed. No new pages were detected beyond the ones already known. I also tested with Burp Suite but did not find anything useful. I noted earlier that the /about page referenced the VM2 library with a hyperlink pointing to a GitHub repository. The link takes me to a GitHub repository that shows the version of VM2, and there appears to be a reference to an issue submitted by Case Hacking Lab. I decided to Google search VM2 3.9.16 exploit, based on my assumption that if a vulnerability was disclosed by Case Hacking Lab, there is probably an exploit POC. The results were promising. I clicked on the exploit.db link. I analyzed the exploit code to understand its functionality and ensure there were no hidden or unintended commands that could execute upon running it. The comments at the beginning provide information about the exploit, including title, date, author, vendor, software link, version, tested platform, and CVE number. Looking at the code itself, it appears that VM2 library is imported, a new sandbox instance is created, an initial command pwd is configured to run, but a note states that it can be replaced. After reviewing the exploit POC code, I'll copy the following code and paste it into the Codify editor page. Running the exploit code as is displayed the working directory shown on the right side, /home/svc. Based on this output, it appears that the exploit code works. Now I need to test to see what other information I can gather. I modified the command from pwd to cat/etsy/passwd. After clicking run, the editor page displayed the /etsy/passwd contents. Let's see if I can execute a bash one-liner. Before I run the bash one-liner, I started the netcat listener on port 1234. I copied a bash one-liner from the Pentest Monkey website. After modifying it with my IP and listener port, I ran the bash one-liner, but it errored out as shown in the browser. Using the echo command shown in the CLI, I created a bash script titled revshell, and I'll see if I can upload it to the target host. Before attempting the upload, I needed to start my HTTP server. I ran the following command shown in the CLI. I ran the following wget command shown in the browser, and I did not get an error. I wanted to verify that the upload was successful, so I ran the ls-la command, and in the output I could see my reverse shell script, but I noticed that it did not have the execute permission, so I'll need to modify that. I ran the following command shown in the browser to first make the script executable and ls-la to verify the permission was changed. Based on the output, it looks like it was successful. I ran the script using the command shown in the browser. Looking at the output, I initially thought the execution had failed. When I looked at my netcat listener, I could see that the target host created a session and I could see the Codify terminal prompt. Now that I'm on the target host, I want to find out where I landed and see the contents of the folder. Based on the output, I was in the SVC account's home directory. I ran the following command shown in the CLI to move back into the /home directory and see what other user accounts were on the target host. Based on the output, I can see two accounts, Joshua and SVC. I got a permission denied message trying to change directory to the Joshua home folder. I'll run the following command shown in the CLI. This will allow me to upload linps with the wget command, then use chmod command to modify the permissions to make linps executable. Then finally use ls-la to verify that linps downloaded successfully and that it is now executable. Based on the output, it appears that it was successful. I'll run the following linps command shown in the CLI. The -a flag performs all enumeration and the -e flag performs extra checks. In the searching tables inside readable db/sql/sqlite file section of the linps output, there appears to be some SQLite 3 databases. The one that interests me is the /var/www/tickets.db file due to the Codify web application. I ran the following command shown in the CLI. The output displays the contents. I ran the strings command shown in the CLI, and the output showed the username Joshua and the hash. I'll copy the hash. I ran the following echo command to create a hash.txt file containing the hash. I also ran the ls-la command to verify that the file was created and the cat command to verify the contents. I will use the hash.txt file to attempt to crack the hash. I'll run the following John the Ripper command to attempt to crack the hash. Based on the output, it appears that the crack password is SpongeBob1. With some credentials in hand, I ran the following SSH command to attempt to log in with the Joshua user account. After hitting enter, I got prompted if I was sure I wanted to continue connecting, which is a good sign. I entered yes. I get prompted to enter a password and I entered SpongeBob1. When I hit enter, I get presented with a welcome message and system information. It appears the credentials worked. Now that I got a foothold on the target host, I ran the following commands shown in the CLI. The pwd, or print working directory, lets me know what folder I'm currently in. The ls-la command allows me to see the contents of the folder. I can see that the user.txt file is in this directory and it contains the first flag. The sudo-l output shows a script called mysql-backup.sh that the Joshua user account can run as root. I ran the following locate command to quickly find out the script's location. Based on the output, it's located in /opt/scripts. I ran the following ls-la command shown in the CLI to view the permissions of the mysql-backup script, and also the cat command to view the contents of the script to see what I'm working with. This bash script appears to be designed to back up MySQL databases to a specified directory. Let's break down the script. The set variables include db_user equals root, sets the database username to root. db_pass equals $bin/user/bin/cat space/root/.creds parenthesis reads the database password from the /root/.creds file and assigns it to the db_pass. Backup_dir equals /var/backups/mysql specifies the directory where the backups will be stored. The password confirmation prompt prompts the user to enter the MySQL password for the root user. The input is stored in the user_pass. The entered password is compared with the password stored in the db_pass. If they match, a confirmation message is printed, otherwise the script exits with an error message. In the backup directory creation portion of the script creates the backup directory /var/backups/mysql. If it doesn't already exist, using the mkdir-p command. The mkdir is short for make directory, and the -p flag tells the command to create parent directories if they don't already exist. The database list retrieval portion uses the mysql command to list all databases on the MySQL server, excluding system databases such as information schema and performance schema. The list of databases is stored in the databases variable. In the database backup portion of the script, for each database in the list, the script will print a message indicating the start of the backup. It uses MySQL dump to create a backup of the database and compresses the output using gzip. The backup file are saved to the specified backup directory with the .sql.gz extension. Looking at the set permissions of the backup directory, after backing up all databases, the script changes the ownership of the backup directory to root:sys-adm and sets the permission to 774, allowing read, write, and execute permissions for the owner and group, and read-only permissions for others. For the completion message, the script prints a message indicating that all databases have been backed up successfully and the permissions have been changed. Reviewing the my-sql backup script, the sections of the script as shown in the CLI contains items of concern. For instance, pattern matching instead of string comparison. The script compares the user password user_pass with the actual database password db_pass. The comparison occurs within the double square brackets using the == operator in bash. This causes pattern matching to be performed instead of strict string comparison. As a result, the user input user_pass is interpreted as a pattern, allowing for the use of wildcard characters like asterisk and question mark. As an example, if user_pass contains wildcard characters like asterisk, there is a possibility that the actual password is unintentionally matched. This would of course allow unauthorized access. Since the script is pattern matching instead of comparing, it may be possible to brute force the actual password. By systematically testing various characters, an attacker can incrementally uncover the complete password. Another possibility is exposure of passwords in the command line. The script uses the -p $db_pass option in the MySQL command. The -p flag is used to prompt the user to enter their password. This can expose the password to process monitoring tools like PS without the space after the -p. This makes it possible for the password to be visible to anyone with access to the process lists. I ran the following PS command as shown in the CLI to see if any MySQL information was disclosed after running MySQL-backup script, but based on the output, there was nothing useful. With no useful information appearing in the process list, another option may be to brute force the password. But before I do, I ran the following wget command to upload pspy32 to the target host. With pspy32 uploaded, I ran the following command shown in the CLI to run pspy32 in the background. With pspy32 running, I ran the mysql-backup script with sudo. As shown in the CLI, I get prompted for a password and I'll enter 1*. After entering 1* and hitting enter, I get a password confirm message, and I can see in the output the MySQL connection attempt where the -p flag appears to have 21 characters, not including the -p. This appears to be the root account password in clear text. Using what appeared to be a password in the pspy32 output, I will try to switch users to the root account as shown in the CLI. Entering the password, it appears I am able to successfully switch users to root. I ran the following command shown in the CLI to change directory to the root home directory and view the contents of the folder. Based on the output, I can see the root.txt file containing the final flag. I ran the following cat command to view the contents of root.txt, and with that I have captured the root flag and completed the host. In conclusion, by leveraging a variety of techniques, I successfully progressed from reconnaissance to achieving root privileges on the target host. The process began with gathering critical information, which enabled me to gain an initial foothold through arbitrary file upload and remote code execution. Once access was established, further enumeration revealed a viable privilege escalation path. This involved a lateral move to another user account via password cracking, followed by exploiting a pattern matching vulnerability in a bash script. Ultimately, these steps allowed me to escalate to root and capture the final flag. Thank you for tuning in to this demonstration of HackTheBox's Codify vulnerable host. Thank you for also checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. If you have any questions, please feel free to leave a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic1, signing off.